Welcome to today's lesson about translations communications. Goal for this lesson is by the end of the lesson be able to describe whether a parent function has been moved up, down, left, right, and by how much. And then we'll finish the lesson by creating functions based on a written description. So when we look at a function that has been transformed, the first thing that we have to do is identify what the parent function is. Okay, parent function always starts with a variable. Okay, we're always trying to group it, and then we're doing some operation to it. So the parent function of this graph, f of x equals x squared. The parent function of the second equation that we have, f of x equals the square root of x. And then the parent function for the third equation is f of x equals x cubed. Now in the last lesson you went through and used function substitution to create the parent function graphs to look at those values. So here is an image of each of the parent function graphs. So the parent function of the x squared is a U-shaped parabola. Parent function of the square root graph starts at 0 and works off to the right-hand side. And the parent function of the x cubed, we call this a snake graph as it comes up from the negative values, levels out at x equals 0, and then increases from that point on. So now, when we look at the transformation part of these graphs, we want to understand what's happening. So in the first function, we have a minus 8 outside of the parent function. And we can see that this graph has moved down 8 spaces. Okay, the second equation, we've got a plus 6 on the outside of the parent function. We can see that it has moved up 6 spaces. Okay, the last graph that we have, parent function minus 2 on the outside. And then when we look at that graph, that 0, 0 point where it levels off, that point has moved down too. So now, when we look at some of these basic operations, what happens when we subtract outside the parentheses or outside the parent function? It does slide our graph down. What happens when we add outside the parentheses, outside the parent function? It sides our graph up. Okay, now looking at the next set of operations we can have. Okay, we understand that this first graph, the parent function f of x is x squared. We see now that that minus 8 is inside the parentheses, inside the parent function. The second one, f of x equals square root of x is the parent. Okay, the plus 5 is under the square root, so it's inside the parent function. And then in our third graph, we've got f of x equals x cubed. Okay, once again, x cubed is the parent. The plus 3 is on the inside. Okay, so when we look at the graphical operations, what's happening? We always want to start with the original parent graph. So we can see the original x squared on top, square root in the middle, x cubed at the bottom, and then we're looking at what's happened to those graphs. Okay, now the first graph, we have a minus 8 on the inside, but we notice that the graph moved to the right 8 spots. Okay, second graph, plus 5 on the inside. Okay, but when we look at the graph has moved to the left 5 places. And then our last equation, we've got a plus 3 on the inside. When we look at the graph there, that one has moved to the left 3 spots. So now when we look at a general rule, what happens when we subtract inside the parentheses? It slides our graph to the right. What happens when we add inside the parentheses? It slides our graph to the left. Okay, very counterintuitive from what you think should happen based on what you see happening to the equation. Okay, so we do have something that helps with this idea of what you trust and what you don't trust, and it's what we call our high-vol rule. And this is a rule that will work in any situation with any parent function, any equation. So when we look at horizontal adjustments, okay, they're inside the parent, inside the parentheses. And then we also have this horizontal head shake that we want to think about. Okay, when you're shaking your head horizontally, you're saying to yourself, don't trust what you see. So if there's a plus inside the parentheses, horizontal head shake tells you you're moving to the left or right. And that head shake is telling you don't trust the sign that you see. So this graph is actually going to move, if it's a plus value, is going to move to the left. If it's a minus value, it moves to the right. Then when we look at our vertical adjustments, okay, vertical adjustments means the graph is moving up or down. Okay, we have a vertical head shake to help us with that. Okay, we're looking at values that are outside the parent function, outside the parentheses. And your head shake rule is telling you that you do trust. If you see a plus outside the function, it's moving the graph up. If you see a minus outside the function, it will move the graph down. So now, this is more of the textbook definition of how those values work. Okay, transformation of any function when we talk about h and k, and we can use that high-vol rule to see why they work. Okay, this 4 is a positive 4. It's outside the parent function, outside the parentheses. So that plus 4 is going to move it 4 units up. The minus 7 is inside the parent function or inside the parentheses. Head shake rule tells us that we don't trust the negative sign. So instead of moving 7 to the left, it's going to move it 7 units to the right. Okay, next example we have down here at the bottom. We've got a minus 6 on the outside. Outsides are vertical. The up-down head shake tells us we trust what we see. That's why the graph moves down 6 units. And then we've got a plus 2 inside the parentheses, inside the function. Okay, head shake rule tells us we don't trust the positive value. So it's not going to move the graph to the right. It's going to move it 2 units to the left. Okay, now the last part you're going to see in your homework is the communications portion. Okay, now we're going to build an equation and we're going to do specific movements to it. So when you're starting to build your equation, you can think about the spots where you can place values. Okay, we've got our parent function of x cubed, and I can put something on the inside or I can put something on the outside. And then it's all based on what the operation is. When I look at down 7, okay, I know that's an up-down movement. Up-down movements are vertical, and verticals are outside the equation. So I know that this value of 7 has to go in an outside spot versus the inside spot. Head shake rule tells me I trust what down is mathematically. Okay, down means it's a minus 7. Okay, there's nothing that's going to go inside the function. So if you're working on your Schoology quiz, you can just put in an NA. Okay, because that's not applicable for the movement of this graph. Next one we've got is our absolute value equation. Okay, once again, we want to understand where can we place things. Absolute value is the parent. We've got the x value inside the parent. We have an inside position and we have an outside position. Now, the movement we want is a right 4. Okay, head shake rule tells me that's a horizontal movement. Horizontals are inside, so I know I'm going to put the number inside, and then I have to look at the head shake rule. Right should be positive, but the head shake rule tells me I don't trust what I see. Okay, so it's going to be a -4 on the inside to get the graph to move right 4 places. There's no outside operations here, so I can put the not applicable if it's on Schoology. If you're just writing the equation by hand, you would leave it blank. Okay, and then the last operation here, we've got 2 transformations. Okay, we have our additional parent function. Okay, the inverse, or 1 over x. Okay, this one's a little bit different. Okay, the parentheses go on the bottom to isolate the variable. And then you have your inside position with dx, and you have your outside position after that 1 over x fraction. So looking at my pieces, I've got an up 1, okay, up down. Up downs are vertical, verticals are outside, so we're using that high-low rule. Head shake rule tells me I trust what I see, so up should be positive, and I'm going to put a +1 on the outside. Okay, now on this one, it shouldn't be an up and a down, so let's change that to a left 6. Okay, left rights are horizontal. Horizontals are on the inside of the parent function. The head shake rule tells me I don't trust the left being negative. So when I put the 6 on the inside, I have to put a +6 on that value. Okay, now the last 2 here, just doing some quick descriptions. Okay, so looking at this equation, try to describe what the +6 is, describe what the +2 is. Okay, pause at this point for a second if you need a little bit of extra time, and then we will show the answer. This graph has been moved left 6 and up 2. Okay, one additional operation that we have here. Okay, we've got a -3 on the inside of the parent, +9 is on the outside. Okay, think about the classification for those. And then the answer, the absolute value has been moved right 3 and up 9. Okay, thank you and good luck on your assignment.